let's talk about finding an equation from 2 points. This is for a straight line. Given 2 points on the line, finding the equation of the line. The procedure, first find the slope from those 2 points. Then you can use point slope form, picking either one of those 2 points to plug into point slope form. Depending on what you're asked, you might need to then solve for y, get that into slope intercept form, or you may be able to just leave it in point slope form. Now, if it happens to be a vertical line, then you can get to step 1, and then somewhere in there, you have to recognize, oh, this is a vertical line. I can't use point slope form. It's just going to be x equal to the x coordinates of those points. All right, so we're going to practice this, and I'm going to demonstrate plotting the 2 points also. That can help give an idea of what the equation should look like, sort of confirm that things are doing what they should, that the slope is the type of value it should be, and so on. You wouldn't have to do that. It's just something that may be helpful. So I have the points 2, 3, and -4, 5. So I'm going to plot those points, 2, 3, and then -4, 5. And so the line through those, I can tell a few things about it, knowing just about how slope works. So I know the slope is going to be negative. And I know it's going to be between 0 and -1, just by like the relative steepness of the graph. It's not steep enough to be all the way to -1. So it's probably going to be a fraction where the top is smaller than the bottom. The rise is less than the run. And then I can tell the y-intercept is going to be between 3 and 4 somewhere. So let's take a look at doing the actual calculations. So the slope, I can do 5 minus 3 over -4 minus 2, or I could do 3 minus 5 over 2 minus -4, getting 2 over -6, or -2 over +6. And I can also look at the graph, since I've drawn that, and say, well, that's down 2, and then right 6 to get from the first point to the second point. So that would also give the -2 over 6. And either way, all of those give then the slope of -1/3. All right, so then I can pick either point and plug into point slope form. So y minus 3 equals -1/3 times x minus 2, or y minus 5 equals -1/3 times x plus 4. So x minus -4 there becomes x plus 4. Two different equations. They're both equations of that line through those 2 points. But I can also solve them and see like either one of those is going to give the same slope intercept form. So this first one, y minus 3 equals -1/3 x plus 2/3. If I add 3 to both sides, but 3 is 9/3, then I get y equals -1/3 x plus 11/3. And the other one, y minus 5 equals -1/3 x minus 4/3. Add 5 to both sides, that's 15/3. -4 plus 15 is 11 again. So it gets that same thing. And 11/3, notice that's 3 2/3, which is between 3 and 4, as I observed on the graph. Depending how you're asked, if you're asked just find an equation, then you can probably leave it in a point slope form. If you have an answer box that has a y equals in front of it, or later on like an f of x or something, then you would need it to be in that form, in the slope intercept form. Right. Next example, I have the points -2, 5 and 2, 5. If I plot those, I can pretty easily see that's a horizontal line. You might even recognize as soon as you see the matching y values that means it's a horizontal line. Or if you calculate the slope, you get 5 minus 5 over 2 minus -2 or over -2 minus 2. But either way, you have 0 on top of a 4 or a -4. And it doesn't matter, it's 0 regardless. Then that should tell you that it's a horizontal line. And even if that doesn't, you can still plug into point slope form. Y minus 5 equals 0 times x plus 2, or y minus 5 equals 0 times x minus 2. And so y minus 5 equals 0 in either case, then you get y equals 5. But you could get the y equals 5 even as soon as you see the same y value showing up twice. That's the first point that could directly tell you that's going to be the equation without doing any other process or anywhere in that. Once you graph it and see it's a horizontal line, once you find the slope, anywhere in that process, you might be like, oh, this is a horizontal line. This is the equation without doing any further work of the process. So that process of finding the equation, you don't have to do every single step if you recognize what the equation should be without that. Next example, here we have a graph. So again, I can do the process step by step, find the slope. Finding the slope, I can either use the slope formula, y2 minus y1 over x2 minus x1, or I can look on the graph and see from the first point it goes up 1 and then right 2. So that's rise over run to get the 1/2. So multiple ways to get to the slope being 1/2. And then I could plug in either point into point slope form. I could do y minus 1 equals 1/2 times x minus 2 and get there. So y minus 1 equals 1/2 x minus 1, add 1 to both sides, and I get y equals 1/2 x. If you have a 0, 0, that's always going to be the easiest thing to plug in. Y minus 0 equals 1/2 times x minus 0. The minus zeros aren't doing anything, so that's just y equals 1/2 x. Or you could recognize this is the y-intercept, so we can plug into y equals mx plus b, y equals 1/2 x plus 0, or again, just y equals 1/2 x. So lots of different thought processes depending what you remember and where your mind goes on that to eventually get to the y equals 1/2 x. All right, and the next example, we have 3, 4, and 3, -2. So if I plot those points, hopefully at the point of plotting those, you would recognize that's a vertical line, or just seeing those matching x values. Or if that's not enough, at the point where you calculate the slope, 4 minus -2 over 3 minus 3 would be 6 over 0, or -2 minus 4 over 3 minus 3. Either way, when we have that 0 on the denominator, it's an undefined. And at the very least, at that point, you should be like, that's a vertical line. And once you know it's a vertical line, then you need to know, okay, so the formula is going to be just x equal to the x coordinate. But you could get there directly as soon as you see those same x without trying to calculate slope or anything else. Or you could get there from seeing the graph, but somewhere in the process, recognize that that's what the equation for that line would be. So that's finding an equation from 2 points.